Video is on the carbonyl compounds, and now I'm on to the reactions of the carboxylic acids. So there are a few reactions that carboxylic acids can do, and we need to know about. So with bases, they form a salt plus water. With metals, they form a salt plus hydrogen, and with carbonates, they form a salt, carbon dioxide, and water. This final reaction with carbonates is used as a test for carboxylic acids. We use sodium hydrogen carbonate, and the equation is the carboxylic acid plus sodium hydrogen carbonate, and these react to form R-CuNa plus H2O plus CO2, and what we observe is the effervescence of the CO2. And we can use a lighted splint to test for this further, because obviously the splint will go out from the CO2. Another reaction is esterification, and this is where we react a carboxylic acid plus an alcohol to produce an ester and water. The general formula of an ester is RCOOR, and the reaction is done by being heated under reflux with a sulfuric acid catalyst. And here I've demonstrated a esterification reaction, and I've colour-coded it to make it easy to understand how to name it and what goes where. So we've got ethanol reacting with ethanoic acid to produce ethyl ethanoate plus H2O. So the alkyl group is in orange, and that comes from the alcohol. But if you're not given the alcohol, you can just think, well, what's only attached to one one oxygen, and that's the ethyl. The next part comes from the carboxylic acid, and that's the ethanoate part. And if you're not given the carboxylic acid, you can think, well, what's alkyl groups attached to two oxygen atoms? And that's this part here. So then, putting these together, we get ethyl ethanoate, and of course the water's the byproduct. Finally then, we can also reduce carboxylic acids, and these are reduced to primary alcohols. We cannot reduce them back to aldehydes. If we want an aldehyde from a carboxylic acid, we have to first reduce it and then oxidize it using acidified potassium dichromate under distillation. The reducing agent is LiAlH4, and the reason we use this and not the NaBH4 is because NaBH4 is too weak a reducing agent, so it won't work. And that's all you need to know for the reactions of the carboxylic acids.